Yeah, I'd like to welcome everybody to the Wednesday edition of the Friday Night Science series. This is a special talk. This is Earthstock week, and so this fits in perfectly. Our speaker tonight is Dr. Jeffrey Bennett. A little bit more about him in a moment. I am obligated to give you some public service announcements. The first of all, if any of you here want in-service credit, if you're a high school teacher, I think you get it for this talk too. Come down and see me after the presentation, and you'll have to sign in. As Earthstock Week continues, tomorrow, Thursday, 4 p.m., in SAC 303, Professor Robert Crease of the Philosophy Department will be giving a talk entitled Lights Out, The Rise and Fall of Scientific Authority. And officially the capstone talk of the week, it is the last talk of the week, 3 p.m. on Friday in the Wong Center Theater. Professor Michael Mann from Penn State will be talking about Return to the Madhouse, Climate Denial in the Age of Trump. No, and that's at the Wong Center, 3 p.m. Wong Center Theater. No politics tonight, right? Or certainly less in the way of politics tonight. It's my pleasure to introduce Dr. Jeffrey Bennett. We go way back. He was a grad student at the University of Colorado when I was a postdoc there, and I was on his thesis committee more years ago than we would like to remember. 1987, actually. I don't know if he's going to tell the story, but he decided when he was in grad school he liked teaching better than he liked doing research, so he became an educator, and he laid out a scale model solar system at the University of Colorado. Later he actually got a real job at NASA as an administrator for a few years, and he laid out one of these on the National Mall in Washington, D.C., and since then he's been an educator. He's been writing books. He writes textbooks. He writes children's books. He writes books for the general public about science, and what he's going to tell you tonight is based on the Global Warming Primer, which is a wonderful, small, very concise book that tells you a lot of the science you really need to know about why our planet is getting warmer. So please, let's welcome Dr. Jeffrey Bennett. And I should tell you, these books down here, these are his books. He's written them. Feel free to come down after the talk and peruse them. You can order them all online.
Thank you very much. Is that picking me up fine back there? Okay, awesome. So I really appreciate you having me here. Thanks to Fred for making this possible for me to come tonight. And very briefly, the one correction I'll make is I didn't base this talk on the book. The book is based on the talk. And that's because when I started doing these talks, I said I was going to answer your questions about the science, the consequences, and the solutions, and I don't want to keep you here more than an hour, and I quickly found out that in an hour I couldn't answer all your questions. So I wrote the book in order to make sure the rest of your questions are answered. It's actually in Q&A format, so you can read that. But I also don't want anybody to accuse me of being in this for the money, and therefore, you can buy the book. That would make me very, very happy. But it's posted for free online at globalwarmingprimer.com, so you can read the whole thing online, find the question that somebody asked you that I didn't get to answer tonight that you want to answer. And along with that, I'll just tell you briefly what I'm doing is I do enjoy speaking to audiences, particularly at colleges. I do quite a bit of it, and I don't accept any money for it, and I pay my own way in general for the travel, so nobody can say I'm earning money off this topic. And if you like the talk tonight, you can tell people in other places that they can apply to me for a free visit, and I'll come visit some elementary schools and things at the same time when I'm out in a place. Anyway, So that's what I'm going to try to do, is demystify global warming, the science, the consequences, and the solutions. And I'm going to try to move pretty quickly so that I can give you some of the basic ideas of what I think are really important about this. And to start off with, I don't think it's going to surprise you that I believe this is the most important challenge we face today as a civilization. For those of you who are young in college right now, this is the challenge that if we don't meet this one, nothing else is going to matter. We need to deal with this one. I'm going to try to explain to you why. And so I'm an astronomer, not a climate scientist. If you get into really detailed questions about climate science, I won't be able to answer them. And so you might wonder, what is an astronomer doing up here talking about global warming? If you've taken any of the astronomy courses, you'll know we cover this topic in astronomy. In fact, one of the most famous climate scientist, James Hansen, began as a planetary scientist studying, in fact, Venus there. So it turns out astronomy is actually a really good way to get at this topic. And so I like to start with what I call a tale of two planets here. So the idea is you see Earth and you see Venus on the screen, and this picture shows them to scale. And what you see in this case is they're both the same size, for all practical purposes. And from other data, not just from looking at them, we know that they have similar compositions, densities, and so on. In other words, for most practical purposes, these two planets are about as close to being identical twins as a pair of planets could be, with one exception. And the one exception is this huge difference in their global average surface temperatures, this one being quite nice, we like it here, and this one being hot enough to melt lead on the surface. And part of my goal in trying to help people understand global warming is to have you think about this question the way a scientist would think about this question. And what you do when you see something like this as a scientist is you say, gee, that's really interesting. Why would two planets that in other ways are so similar to each other differ in this one particular way? So what we do in science is we hypothesize. We come up with a possible explanation, and then we test that explanation out. What is a possible explanation for this? Well, the thing that comes to mind for most people first is the fact that Venus is closer to the Sun, which it is, of course, but this is that scale model solar system outside the National Air and Space Museum that Dr. Walter mentioned. And there you can see the Sun at 1/10 of actual size, Mercury, Venus, Earth. So you can kind of imagine that this was a giant bonfire right here where the Sun was. Well, sure, it's going to be warmer at Venus than Earth, but when you look at the relative distance there, it's not going to be warmer by enough to explain that. It's not going to work. And you can calculate out and show. And in fact, it's actually more interesting than that because, Earth has some clouds and clouds reflect sunlight. Venus is completely covered by clouds, so they reflect a lot of sunlight. And in fact, because Venus's clouds reflect so much sunlight, Venus actually gets less sunlight on its surface than Earth does, even though it's closer to the Sun. And so if this were all there were to it, you'd actually expect Venus to be colder than Earth, not warmer. So this first hypothesis about distance fails. Therefore, we need to come up with other ideas. We could spend a lot of time making various hypotheses, but I'll just tell you the answer. The answer is the greenhouse effect. This is what explains the huge difference in temperature between Earth and Venus. And you've probably heard about the greenhouse effect before, so I just want to very briefly review it for you. Planets get their energy primarily from visible sunlight, but they return their energy to space. Well, some of it they reflect right back into space from clouds or the surface. But the energy that the ground absorbs is returned to space not in the form of visible light. If it was visible light, they'd be glowing in the dark, and we know that doesn't glow in the dark at night on our surface. It returns it in a form of light that we can't see with our eyes called infrared light, which we can detect with infrared cameras. So the red arrows in this picture represent the infrared light that by which planets return their energy to space. The blue dots in this diagram represent what we call greenhouse gases, the three most important on Earth being water vapor, carbon dioxide, and methane. And those are gases that happen to be very good at absorbing infrared light. And so when infrared light hits one of these molecules of a greenhouse gas, it gets absorbed and then re-emitted, but re-emitted in some random direction. So the result is that the infrared light takes this complicated path before it finally gets out. And overall, what that does is it's essentially slowing the escape of heat from the planet's surface so that we get additional energy and heat at the surface and in the oceans and in the lower atmosphere of a planet. If you want to remember how this works, a really good analogy is a blanket. If you go outside on a cold night and you wrap a blanket around yourself, the blanket doesn't give off any heat. So why do you warm up? The reason you warm up is because the blanket slows the escape of your body heat. So the greenhouse effect is like a blanket for planets. It slows the escape of a planet's own heat, and that's what causes it to warm up. So now remember, I told you I want you to think like a scientist here. So if you're thinking like a scientist and you'd never heard of this before, your natural reaction as a scientist would be, well, gee, Jeff, that's a nice story. Why should I believe you? So why should you believe me about the greenhouse effect? The answer is because we have evidence to show that things really do work this way on planets. What is that evidence? Well, first, we can actually measure the greenhouse effect in laboratories. You know, in essence, you put gas in a tube, shine different wavelengths of light at it, and measure what happens. This is not new science. This picture comes from a book published in 1850, or published later, but from an experiment done in 1859 by John Tyndall, where he was measuring the greenhouse effect. And only fairly recently did I learn that he was not actually the first person to measure the greenhouse effect. The first person to measure the greenhouse effect did it 3 years earlier in 1856. And how come we haven't heard about this person very much? Because this person was a her, Eunice Newton Foote, who was not allowed to present her own work before the Scientific Academy at the time, so a man had to present it for her. And as a result of that, it kind of got forgotten a little bit, but she was actually the first to do this work. But the key point is, we've been measuring the greenhouse effect in the lab for more than 160 years. These measurements are very, very precise today. And once you have those measurements, you can then take them and use them to calculate, to predict what the temperature of a planet would be with or without the greenhouse effect. That's our second test. And what we find is when we calculate planetary temperatures, or moons with atmospheres, with the greenhouse effect, we get correct answers. When we do it without it, or any other try that we make, we get incorrect answers. And that means there's just absolutely no doubt that this really is the way that planets get heated up above what they would otherwise be by sunlight coming in alone. And the calculations with the greenhouse effect can get pretty complex, but I just thought it's worth showing you. There's a picture out of my children's book on the topic here. This is the equation without the greenhouse effect. All it is a root, a fourth root there. It's very simple to plug in on a calculator. And the interesting thing is, if you look for Earth, you find that without the greenhouse effect, Earth's average temperature, that's a negative sign there, would actually be well below freezing. In other words, without the greenhouse effect, this planet would be frozen over. We could not be here. And that allows me to come back to the tale of two planets and finish what we started. So what is the answer to our tale of two planets? It's that on Earth, our planet happens to have enough carbon dioxide naturally existing in our atmosphere so that instead of being frozen over, we have this nice, pleasant temperature here. In other words, the greenhouse effect is not a problem. It's wonderful. It is the reason we're here. The greenhouse effect is a very good thing for life. Well, what's going on with Venus? Venus has about 200,000 times as much carbon dioxide in its atmosphere as Earth does. So think back to that diagram I showed you, 200,000 times as many blue dots. And that is what gives Venus this extreme greenhouse effect and extremely high temperature. So the way I like to think about it is, the greenhouse effect is a very good thing for life, and Venus is absolute proof that it's possible to have too much of a good thing. And in a lot of ways, we're almost done with the science of global warming. Because here we absolutely know more greenhouse gas, including carbon dioxide, means higher temperatures. And the reason that worries us is because measurements show that we are, in fact, increasing the carbon dioxide concentration on Earth. These are measurements that have been made since the late 1950s. The units here, parts per million, what does that mean? So 315, where we were back in the late 1950s, that means that out of every 1 million molecules of air, about 315 of them are carbon dioxide molecules. That's actually a very small amount, right? 315 out of 1 million. Why is it so important? Because they're the ones that absorb infrared light. Most of our atmosphere is made of nitrogen and oxygen, but they don't absorb the infrared light, so they don't have an effect on our temperature. And back in the 1950s, since that time, we've gone from 315 up today to over 410 parts per million of carbon dioxide. And of course, the next question you might be thinking of is, yeah, but how do we know why? And the answer, I don't have time to go into, but in the book, which you can read online for free, you'll see 4 solid lines of evidence, including carbon isotope evidence, that leave no doubt at all that the reason this is going up like that is the burning of fossil fuels, the number one reason, burning of fossil fuels. And so when you see that, the only question that might be left in your mind about whether we should be concerned about this is, well, even though we know we're doing this today, could it be that nature does this sometimes anyway? And to find that out, you would like to know, well, how's the carbon dioxide concentration gone naturally before we were around? And you might think that would be a very difficult question to answer since we were not around. But it turns out there's a lot of ways to measure what the carbon dioxide concentration was in more distant times, and perhaps the best is this here called ice core drilling. So the scientists go down to Antarctica, they drill down into the ice, they bring up drill-shaped tubes of ice, and when you look at that ice, well, you have to think, well, what is that ice? Well, the ice that's in Antarctica is basically the snow that fell a long time ago, year after year, and didn't melt. And therefore it piled up, and because of seasonal changes and stuff, you can actually see the layers in this ice. So it's almost like counting tree rings to look at the layers in this ice. You go down 10 layers, you're seeing snow that fell 10 years ago. You go down 100 layers, you're seeing snow that fell 100 years ago. And in that ice, there are trapped bubbles of air. And in essence, you go in and measure their carbon dioxide concentration. And now you know what it was back whenever that snow fell. And to me, one of the most amazing scientific things that's ever been done is that scientists down in Antarctica about a decade ago drilled down 2 miles through the ice. So they have a 2-mile long ice core. Obviously, they have to cut it into pieces, right, in order to put it in freezers and store it. And it turns out when you count the layers, that at the bottom of those 2 miles, they were bringing up ice that represents snow that fell 800,000 years ago. And therefore, we have an 800,000-year record of carbon dioxide on Earth. And there it is. That's 800,000 years ago, moving towards the present here, and then a zoom out of the last 50 years or so. And what do you notice? Well, the first thing you notice is, sure enough, the carbon dioxide level does vary naturally. It varies quite a bit naturally. However, throughout that whole period, it never fell below about 180 parts per million, never went above about 280. In fact, around the time of the beginning of the Industrial Revolution, it was 280 parts per million. And now we've shot it up to 410 and rising, which means today we're now 45% higher than Earth was at any time in the past 800,000 years. If you extrapolate this curve upward and say, if we keep doing what we are doing right now, what will happen? You find that in only about 50 years, we will be at double the pre-industrial value, 560 parts per million. So if you're a college student today, you won't be much older than I am right now, and will be double the pre-industrial concentration. And then if we continue that, by the middle of the next century, we'll be approaching 1,000 parts per million. This is what makes us think we've got a problem. And I like to summarize it by saying that the basic science of global warming is as easy as 1, 2, 3. So what is my global warming 1, 2, 3? It's what we've already talked about. It is a scientific fact that carbon dioxide, a greenhouse gas, makes Earth warmer than it would be otherwise. Who disputes this fact? Among scientists, no one. I happen to be here in New York primarily for a debate against one of the lead people who denies that we have a serious problem, and even he agrees this is correct. Fact number 2, the use of fossil fuels is increasing carbon dioxide in the atmosphere. The data that I showed you, there's no doubt about that either. It's directly measured. If you take 1 and 2 and put them together, more greenhouse gas means warmer temperatures, and we are putting in more greenhouse gas. Number 3 is actually quite obvious. We expect global warming to occur. And in fact, again, there is no scientific dispute about this at all. Again, even that person I debated on Monday night acknowledges this is true. What's he debating? What are other scientific so-called skeptics debating? None of them debate that global warming is going to happen like this because it's so simple. What they're arguing about is how fast it's going to happen and how bad it's going to be. The skeptics are saying, yes, it will warm up, but it won't be so bad. The rest of us, the 97% of climate scientists that you hear about, are saying, we actually think it's going to be pretty bad. But that's the debate. And that's what you miss in the media very, very often. And so one of the questions that comes to mind, I've taught this stuff to lots of people. I've done this with elementary school kids. They get this. And so if it's so easy to understand the 1, 2, 3 science of global warming, why is it that so many politicians seem to have such a hard time with it? So my quiz question for you tonight is, who was the first major global leader to get up on the international stage and say, you know what, 1, 2, 3, we got a problem here? So Al Gore is the person that most people guess. I will tell you that I suspect that Al Gore was in fact aware of this problem and understood it before any other major global leader. However, in 1989, Al Gore was a senator from Tennessee. He was not a major global leader. But there was another major global leader who recognized this, who got up and gave a speech to the United Nations in 1989. And this is what she said. What we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. That's Margaret Thatcher. If you're not familiar with Margaret Thatcher, she, along with Ronald Reagan, is considered to be one of the 2 founders of modern conservatism. So you can see there's no doubt in her mind. She's basically saying in that little excerpt there, the 1, 2, 3 science, and she's not only saying, yes, it's going to warm up, she said it's damaging and dangerous. And she went on to talk about how it was critical that we do something about it. You can watch the entire speech. I have it posted, the link on my website, globalwarmingprimer.com. And so if anybody ever tries to tell you that global warming is some sort of liberal or democratic issue, just point out that the very first global leader to speak out and say this is real and this is serious and we need to deal with it was one of the founders of modern conservatism. Just a side note, you might wonder why she was ahead of the curve on this. And I believe the answer is the fact that before she became a politician, she was a research chemist. She had a PhD in chemistry. So she was a scientist. She understood the science. But another thing to notice is this warming is in fact happening as we expect. 1, 2, 3, no surprise here, right? This is the 0 line is the 20th century average. Blue is cooler, red is warmer. So it's pretty obvious that the temperature is going up. But it is just kind of interesting to look at 1989 here when she gave that speech. So if you cut the graph off right here when she cut that speech and you only look to the left of that, At that point in time, if you were only looking at the data, you could have almost believed it was just random what we were seeing, right? So if the data weren't showing a major warming yet, how was she so sure that we had a problem? And the answer, again, is the 1, 2, 3 science is so simple and obvious that there was no doubt in her mind. Now, I used to try to talk about the various skeptic arguments that people make against this. And then after I put the book together, I realized, okay, I have them all in the book. So I have 4 major skeptic arguments that you commonly hear out in the media. If you want to know what's wrong with them, you can read it in the book or online. I just want to talk about a couple of the things that you might commonly hear. And one of them is, well, maybe it's not us. Well, first of all, we know it should be us because the 1, 2, 3 is so simple. But then you have to ask, well, what else could it be if it's not us causing the warming? And the only really possible natural factor that could possibly be doing this besides us would be the sun. So let's look at the data. Well, here, this is the same temperature graph that I showed you before, except for instead of bars, it's showed as a smooth curve. And this is the amount of energy we're receiving from the sun, because the sun does vary very slightly. And if you look from 1880 to about 1950 or so, you could easily believe that the sun was causing this, right? Because they seem to go together quite nicely. But now if you look at the last few decades, the sun's gone down and the temperatures kept going up. That means it's not the sun. There's a whole bunch of other ways we also know it's not the sun, too. But the point is, it's not the sun. Again, lots of different skeptic debates that you might hear that I don't have time to talk about right now, but I want to go to one more, which that you often hear, which is that the climate varies naturally. So what are we worried about? So I want to talk about that. This graph is the same one I showed you before the 800,000-year record of carbon dioxide, only this time there's a second graph above it, which is the corresponding temperature on Earth at those times. And if you look at that, there's a few things you notice. First of all, you notice that the temperature varies quite a lot. These are degrees Celsius on here, so for Fahrenheit, they'd be almost double. And it varies so much that when we're down at these bottoms here, we're in ice ages, when, for example, New York is covered under a mile-thick sheet of ice. And at the tops, it's warm enough that we're in, like we are today, what we call interglacial periods, when the temperature is much, much warmer than it is down in the ice ages. Another thing you'll notice is that they're correlated. When the carbon dioxide concentration is high, the temperature is high. When it's low, the temperature is low. Why? 1, 2, 3. That's exactly what we expect to happen. Just more evidence that the 1, 2, 3 science is correct. So why should we be worried if the climate varies naturally? Because look what we're doing to the carbon dioxide concentration today compared to anything it did in the past 800,000 years. Now you look at the temperature. We expect there to be a lag of a few decades. It takes time for the climate to respond. So if this starts happening to this, we're in big trouble, right? The temperature would start rising quite dramatically, even more than what we're seeing today. And in fact, going back to the skeptic debate for a minute, really the only thing they're claiming is that they think there might be some natural feedback that will prevent it from going much higher than it is today. And the reason most climate scientists disagree with them is because we don't see any natural factor that could possibly do that and mitigate it. And in fact, there were times in Earth's history when the carbon dioxide concentration was much higher than even these past million years. You go back to dinosaur times, the concentration was over 1,000 parts per million, and guess what? There were no ice caps at those times either. So we know it can get a lot warmer just from the data. They argue about models. It's not just models, it's the actual geological data that prove that the temperature, we should expect it to go a lot higher due to what we're doing with carbon dioxide. So that's the basic science of global warming. What I want to turn to next, I said science, consequences, solutions that I would talk to you about, is the consequences of this. there's lots of different consequences from global warming, but I think an easy way to get your mind wrapped around them is to group them into 5 basic categories. So the first basic category is what we call regional climate change. And so the idea is I've been talking about global warming, meaning the global average temperature, but different places are going to warm by different amounts. That's why a lot of scientists prefer the term climate change. To me, the two are interchangeable. So this is a map that NASA put together that shows you regional temperatures around the world. The neutral white is the 20th century average, blue is cooler, red is warmer, and you can see here that this says it's for the period 1880 to 1884, but they made it as a movie. And here you see the years going by and the regional temperatures changing. The climate does change quite naturally. And as we go into the 30s and 40s, the middle of the last century, you don't really see any pattern at all. But keep watching. 1980s, 90s, 2000s, 2010s. I think you can see a pattern now. It is warming everywhere, and particularly in the Arctic regions. And this has a lot of other consequences besides just the changing temperatures. For example, this graph here, it's kind of a complicated graph, so I won't talk too much about how it was made. James Hansen made this. But what it shows is basically temperatures over northern hemisphere land places all put onto a normal distribution. If you've taken statistics, you're familiar with bell curves, and what you see is in the summertime, most days are normal. Some days are colder than normal, some days are hotter than normal, and a few are extremely cold or extremely hot. And this is the graph, normalized graph of temperatures for the period 1951 to 1980. Then what James Hansen did was he remade the graph for the most recent 10-year period that at least he's done the graph for, and there it is. And what do you notice? The whole graph has shifted over to the right. If you know statistics, it's shifted a full standard deviation to the right. And what that means is today's normal is what we called hot a few decades ago in the summertime. That is a major change that we are seeing in the way our summertime temperatures go. And this has lots of other consequences. In places like Colorado, where I live, it leads to more wildfires. In other places, it leads to more droughts, more floods. It causes the range of species to change. You've probably heard about mosquito-borne diseases that are spreading to areas that they didn't ever used to exist. That's because the changing temperatures are making it possible for the mosquitoes to move into different areas. So it has many consequences. The second major effect of global warming is an increase in storms and extreme weather events. And we see this. It's hard to miss the fact that there's more extreme weather events going on than there used to be, and the data clearly show that there are. It's worth mentioning for a moment that this should not surprise you. And the reason it should not surprise you is because remember what the greenhouse effect is. It's trapping more heat and energy in Earth's oceans and atmosphere. And what causes weather? Heat and energy in the oceans and atmosphere. More of it, you expect more. And since I know you're a pretty sophisticated audience here, I'll give you some numbers they shock me. You can actually measure how much extra energy is being added to the global climate system as a result of our increasing greenhouse gas concentration. And it turns out, the measurements are usually done in power. It's a half a watt per square meter. But if you translate that, that means we are adding 250 trillion joules of energy to the climate system every second, which, to put it in terms that'll mean more to you, is the equivalent energy that we'd be adding to the system if we detonated 4 Hiroshima-sized atomic bombs every single second. That's added energy to the atmosphere and oceans. With that much energy being added, it's almost surprising that we're not seeing even more extreme weather events. The third major effect is the melting of sea ice, that Arctic warming. This does not affect sea level because that ice is already floating, but it has lots of other consequences. One of the most worrisome, I think, is that, remember, ice reflects a lot of sunlight, water absorbs it, so as we reduce the ice coverage in the Arctic Ocean in the summertime, it actually amplifies all the other effects of global warming that we would be seeing. The fourth major consequence of global warming is the change in sea level, rising sea level. And that happens for two reasons. One, the ocean water actually expands as it gets warmer. And two, the melting of landlocked ice, which then flows into the ocean and raises sea level. And sea level has already risen about a foot over the past century just due to that thermal expansion of water alone. And a foot in sea level rise often doesn't sound like much to people, but as you all know in New York from Hurricane Sandy a few years ago, during a storm, that 1 foot increase is greatly magnified by the storm surge and is likely a major reason why we saw so much damage. We will see at least another foot of sea level rise in this century just due to thermal expansion of water, but then there's the melting of ice on top of that. And unfortunately, it turns out that this is one of the biggest uncertainties in climate science, is scientists don't have a really good grip on how fast ice will melt. We can measure exactly how fast it is melting today. The GRACE satellites do that. But it's difficult to know how that will change in the future. And as a result, there's great uncertainty in how much sea level will rise in the years to come. But most of the scientists I talk to guess that we'll probably see about 1 meter of sea level rise by the end of this century, so 3 feet or so. Think about the impact here on Long Island of this much sea level rise when some of you college students will still be alive. In worst case scenarios, it could be significantly more than that. The red here shows a 1 meter sea level rise. What's flooded, the yellow represents a 6 meter sea level rise. Now, I should point out, I am trying to scare you a little bit, but I don't want to scare you more than you deserve to be scared. Nobody thinks ice can melt faster than like 6 meters at the worst case, and probably not even that by the end of this century. But if we keep doing what we're doing, eventually the ice caps will melt completely. By eventually, I mean thousands of years. This is not an immediate concern. But I just think as a mental exercise, it's interesting to think about it. Because if we completely melt the ice cap, sea level will rise more than 200 feet. So it gives you this interesting image of our descendants a couple thousand years from now needing deep sea diving equipment to visit the ruins of today's coastal cities. The fifth major consequence of global warming is what we call ocean acidification. This is the one that you hear the least about, except maybe at places like Stony Brook, where it's studied quite a bit. But in the media, it's hardly ever mentioned. What is ocean acidification? Well, it turns out we know how much carbon dioxide we're putting into the atmosphere, and we know how much it's going up in the atmosphere, and we find only about half of what we're emitting by burning fossil fuels is staying in the atmosphere. The other half is being absorbed by plants, by the soil, by the oceans. And in the oceans, that carbon dioxide dissolves and makes the ocean water more acidic than it would be otherwise. And ocean acidification has been tied to coral bleaching, to reductions in fish stocks, and so on, to the point that I've talked to a few political scientists who believe that ocean acidification could actually cause more total human damage than the other 4 effects put together, because so many people around the world depend on the ocean for food, could lead to the starvation of 1 billion or more people, this problem alone. I told you I wanted to talk about the science, the consequences, and the solutions. And so let's get to the last part. Why are there solutions? Why is this a solvable problem? I believe this is a problem we can solve. Why do I believe that? Because we understand it. What do we understand about this problem? We understand how it's caused. This problem is being caused by the burning of fossil fuels. That makes the solution kind of obvious, doesn't it? Stop doing that. Now, of course, the difficulty there is we kind of like what we get from burning fossil fuels. We like all the lights on and the air conditioning and our driving our cars and stuff like that. So if you try to sell people on just stop burning fossil fuels and go back to living the way you would be without all that energy, nobody's going to buy it, right? We need technologies that allow us to replace the fossil fuels with something else. But guess what? We already have that technology. There's three basic technologies that we can use to replace fossil fuels. The first is efficiency. You don't usually think of efficiency as an energy source, but if you can get the same amount of energy with less fuel, that's just like finding new fuel. Second is renewables. There's tremendous potential in wind and solar and so on. And the third is nuclear. Had some fun conversations about this today. I know a lot of people have opinions about nuclear, but whatever your opinions about nuclear are, one thing about it is it doesn't release any greenhouse gases, which means if your concern is global warming, it is a solution to the problem. I believe we can actually do it in ways that would be safe and solve the waste problem and other stuff. Maybe during the Q&A you'll want to talk to me about that. But the key point is, I don't even know if we need one, two, or all three of these things simultaneously. The point is, between them, if we wanted to, we could stop using fossil fuels today and still have just as much energy and lifestyle as we are used to. And of course, there's all kinds of really amazing sources on the drawing board that people are working on for the future. And so the question that usually arises is, if we already have the technology to solve this problem without hurting our lifestyles, why aren't we? The answer is cost. Now, I have to warn you. Up until now, I believe that everything I have told you is an absolute fact established by science. Now we're going to start talking some economics, which means now we're getting more into things that are a little more difficult to quantify and measure, and things that involve my opinions. So we're leaving the fact-based portion of the talk and going into the opinion-based portion of the talk. But here's what I believe, and I believe it's supported by economic evidence. The reason we are told that we cannot simply switch over right away is because fossil fuels are cheaper than other sources. Renewables are getting close, but fossil fuels are cheaper. I believe that is false. Why do I believe that? Because of what economists call externalities, which I think a simpler word for it is socialized costs. In other words, there are costs to fossil fuels that you don't pay when you buy them, but you do pay them later as a society. Some of these costs are difficult to measure, but some of them are not. For example, we all know that fossil fuels, besides causing global warming, also cause air and water pollution. Air pollution makes people sick sometimes, causes asthma attacks, puts people in the hospital. You can actually count how many dollars we spend on that. According to the National Institute of Health, we spend as a country at least $120 billion a year, likely closer to $200 billion a year, on direct hospitalization costs of air pollution. That wasn't even including water pollution. And that doesn't include lost work days and all that other stuff. That's just the actual money. So that's real money. That money is being spent. It's just you don't pay it when you buy the fossil fuels. You're paying it through your tax dollars and your insurance premiums. But you are spending that $120 billion a year. We also know that fossil fuels, well, we spend a lot as a country to make sure that the routes around the world are safe for our transport of fossil fuels. According to the Department of Defense, we spend at least $100 billion a year baseline cost for protecting the fossil fuel supply. That does not include the cost of any of the wars we've been in the last 20 years. That's just the baseline to have the fleet around to protect the global fossil fuel supply. There's direct subsidies and tax write-offs for fossil fuel production. You actually hear about this one more than the others, but this one's actually small compared to those first two, $20, $30 billion a year. But the interesting thing is when you add these numbers up, we're getting close to $300 billion a year. And again, not imaginary money, real money that you're spending as taxpayers and through your insurance premiums. $300 billion a year. I like that number because it turns out it's an easy one to work with in this context, because it turns out as a country, we use about 150 billion gallons of gasoline per year. So if you divide, you find that these three things alone mean the actual cost of our gasoline is about $2 per gallon higher than what we pay when we buy it. And that's only the beginning. Think about terrorism and totalitarianism around the world. Al-Qaeda, ISIS, Iran, Russia, all the bad things bad people do around the world. How are they able to do all those bad things? Well, because they have money to fund their bad things. And where'd they get their money? We gave it to them by buying their fossil fuels. That cost is probably far larger than those other three. There's environmental costs and so on. And in fact, the International Monetary Fund in 2015 did a study and concluded that globally, we subsidize fossil fuels to the tune of $4 trillion per year, about $1 trillion of that in the United States. In other words, the true cost of fossil fuels to us as a society is about $1 trillion a year more than we pay when we buy them. If that was being paid when you bought them, no one would buy them because everything else, nuclear, renewables, efficiency, would be much, much cheaper. So how do we deal with a problem like this? Well, you can talk to economists. And the interesting thing is if you talk to liberal economists, they will tell you that the way you deal with a problem like this is by putting on a carbon tax that reflects the true cost of the fossil fuels. And if you talk to conservative economists, they will tell you that the way to deal with this is by putting on a carbon tax that gives you the true cost of fuels. In other words, economists across the political spectrum all agree that the way you deal with this most efficiently is by pricing it into the market. Now, I really like this because I happen to be a free market believer. So I think of this as the free market solution to global warming, which is putting on a carbon tax. And you can see there's a group of Republican administration officials from the past, not the current one, that even called this the conservative answer to climate change. And now you might be thinking, how can conservatives think a tax is the answer to anything? They don't like taxes and the government getting more money. But that's because there's a clever twist to this plan that they've picked up on that was actually first adopted by a group called the Citizens Climate Lobby. And the idea is what's called the tax and dividend plan. So the idea is you put on a carbon tax so that the market reflects better the true cost. Now, if you really put a carbon tax on that had the true cost, that $1 trillion a year subsidies, right immediately, we'd crash the economy. So what you want to do is put it on a small amount at the beginning and gradually have it increase over time so that we can adjust to it. But their idea is that then you take all that revenue that the government's receiving, and every month the government mails out a dividend check to every taxpayer, equal dividend checks to every taxpayer, that represents all the money that was collected by the carbon tax. And therefore, this plan does not affect the government's total revenue. Every dollar that the government received, it gives back to the taxpayers each month. And according to these conservatives, they said about this plan that this new climate strategy, this tax and dividend plan, will strengthen our economy, reduce regulation, help working class Americans, shrink government, and promote national security. All these wonderful things. It almost sounds like magic to believe that one policy could do all those things. I actually believe it would happen. There's people, again, we're in the opinion-based part of the talk, but it's worth talking just for a moment, break this out. Why do they think this would happen? How could this policy strengthen our economy? Because we are currently overpaying for energy. When you consider the socialized cost, we're actually paying way more for our energy by using fossil fuels than we would be if we were using any of those other sources. Therefore, if we switched over, we'd be getting just as much energy as we are today for less total money, which means our whole economy will strengthen. How does it reduce regulation? Well, why did Obama, for example, put on all these regulations about greenhouse gas emissions and so on? The reason why, if you look back, is because in 2009 he tried to pass a version of the carbon tax and it failed. Without that tax, regulation was the only tool left. But I believe if you had the tax, you wouldn't need any regulations. The market would take care of it. People would have the incentives to buy the other sources. How does it help working class Americans? Those dividend checks. Remember, everybody gets the same dividend check every month. Well, now there's always going to be exceptions, like truck drivers, for example, would have a tough time with this. But on average, wealthy people use a lot more energy than average people. which means that on average, the dividend check that most Americans get every month will be more than what they spent on any tax they paid. It'll only be the wealthier people who use a lot of energy that'll be paying more tax than they get back in the dividends. How does it shrink government? Well, you don't need as many regulations, so you don't have to have as big of a government. And how does it promote national security? Because you're not giving money to terrorists anymore. In my opinion, when you think about these things, this is so obvious, it's almost to me mind-boggling that everyone hasn't adopted it yet. In fact, a bill to do just this was introduced on a bipartisan basis in Congress this past December. It hasn't moved very far since then. But when you think about all the good things, I like to summarize what it would all mean with this cartoon that I love from a guy named Joel Pett down in Kentucky. And you can see the guy at the podium talking about all the wonderful things that would happen if we adopted this kind of policy, and the person in the back saying, well, what if it's a big hoax and we create a better world for nothing? It's win-win. There's no downside to solving this problem as far as I can see. And so the last step then is, how do we get people to take action on this? And to me, the way you do that, or at least one strategy, is to try to personalize it. I've been talking in a very global sense about the problem, the consequences, the solutions. Personalize it. And the way I like to do this is, if you think about it, on average, there's about 25 years between generations. In other words, on average, you are 25 years younger than your parents, 50 years younger than your grandparents. So if you turn that around, that means on average, 50 years from today, your grandchildren, if you have any, now or in the future, 50 years from today, on average, your grandchildren will be exactly the age you are now. So if you are a professor emeritus right now, your grandchildren will be professor emeriti in 50 years. If you're a college student right now, your grandchildren will be in college in 50 years. So I want you to write a letter to your grandchildren and seal it in a time capsule for them to open 50 years from now. And this is what I want you to write. Dear grandchildren, as I write this in 2019, many people are arguing about whether global warming is a real problem, and if so, how serious it will be for you when you are my age. I have examined the evidence and I have decided to, and then you fill in your decision about what you decided to do. Hope your world is a good one. Love, you. What will they think when they open that letter 50 years from now? Will they think, gosh, I wish you had done something about this problem that's ruined my world? Or will they be thinking, thank you for having taken action and made this incredible world that I'm growing up in today? And so I'm basically going to stop there. I'll remind you, the book has the rest of the questions that I didn't get to tonight, Global Warming Primer, and it's posted for free online at globalwarmingprimer.com, and you can see where else I'll be talking there. And as I mentioned in the beginning, reminder, if you like this talk, tell people. If somebody gets me a good audience, gets me to schools at the same time, I will come at my own expense and for free give the talk anywhere in the United States. That is my children's book on the same topic, and you can see it there being read from the International Space Station. So you can watch the video of that at storytimefromspace.com. I didn't hook up the sound, so you won't hear him talking, but you can see he's in the cupola of the space station reading the books, and you can watch all those videos for free. Last couple little advertisements. For the eclipse a couple years ago, I made an app to help you find your way to the eclipse. You can zoom on down, figure out where you should be, and it will work for the next eclipse that comes up here near New York in 2024, as well as other eclipses in between. It's completely free. There's no ads. We don't track anything, so just download it, please, for your phone and tell other people about it. Put a lot of effort into it, so we want to make sure people are using it. And then finally, those are all of my children's books, books for the general public, textbooks. There's my Twitter name. You can go on and become one of the half dozen people following me. And thank you very, very much. So I'm happy to take some questions. And question? Oh, thank you very much.
Hi. How should I respond to people when they say that we're at the point of no return when it comes to climate change, that there's nothing we can do to fix it?
So, that's actually a really interesting question, right? Could it be that we already... Oh, the question is, how do you respond to people who say we're already past the point of no return? So could it be that where we are, 410 parts per million, is already too high? No one really knows. So first off, don't give up until we really, really know. Secondly, actually, I think we probably are already too high. However, people are working on technologies that in principle could actually draw carbon dioxide out of the atmosphere and bring the concentration back down. We do not have that technology today, but I think in a few decades we might well. And so as medical professionals will tell you when you encounter a bleeding patient, first stop the bleeding, right? Stop making the problem worse, and that will buy us time to develop the technology to make it better.
As you were saying before, you were talking about CO2 levels and how during the dinosaur period that they had gone up substantially. What caused them to come down then?
Oh, I don't know exactly. I bet some of the geologists in the audience could probably speak to that. There's various reasons why the carbon dioxide level changes over time through natural processes. But for example, in the case of the 800,000 year record, these cycles of ice ages we've been in, that is, we think, triggered by something called the Milankovitch cycles, which are small changes in Earth's orbit and axis tilt that change the amount of sunlight hitting the Earth. So what happens is, let's say that the cycles are moving in a place where we start to get a little bit more sunlight. That warms up the Earth a little bit. It won't be enough to explain those huge changes, but it warms the Earth a little bit. That melts a little bit of ice, so we reflect less sunlight, absorb more. And also, it turns out the oceans, if you think about a can of soda, if you warm it up, it releases its carbon dioxide faster. In general, the warmer the oceans are, the less carbon dioxide they can hold. So as it warms up a little bit, the oceans release carbon dioxide that adds to the atmosphere. That causes it to get even warmer, which releases even more, and in addition causes more water vapor to evaporate. Water vapor is a greenhouse gas too, makes it even get warmer. So you have this reinforcing feedback that drives us up until we're at the peak of the cycle, and then the natural cycles, the sunlight's changing, and we start to come back down through the opposite of that process. So I don't know the answer on the longer term ones, but it's something similar to that, some mechanism that is affecting the release of carbon dioxide on the planet. The oceans store a lot more carbon dioxide than the atmosphere does.
So the governor of this state has proposed a climate action plan that would rely heavily upon the concept of carbon neutrality and carbon offsets. I just wonder what your thoughts are. I don't remember this being part of the Paris Accord, and I'm not sure that it would result in reducing CO2 input, but I'd like to hear your thoughts.
I don't know a lot about that one. Most of the carbon offsets that I've seen are fine in terms of a small number of people using them to offset. It's not clear to me that this could work globally. So when you look at it from a global perspective, it doesn't seem like a solution. It could be that locally or state level it might make sense. I don't know enough about it to say. I will say, but another important thing, nobody's asked me about this yet, maybe you would, maybe you wouldn't, it often comes up, is I get people a lot of times saying, well, yeah, but who cares what we do? China and India are emitting way more greenhouse gas than we are. Well, so here's what I believe, and this again, remember, I'm a free market evangelist. I believe strongly in the free market with proper regulation. I believe if we put on this carbon tax, we would see such rapid innovation in other energy sources that within a few years, the other things, renewables, nuclear, so on, would not only be cheaper than fossil fuels with the carbon tax, they'd be cheaper than fossil fuels without the carbon tax. And as soon as that happens, everybody in all those other countries is going to come running and knocking on our door and say, can we buy that from you? Because of course they want the cheaper energy source, particularly if it's a lot cleaner. And I actually believe that one way or another, that is going to happen. I think this problem will be solved, and it will be solved through these technologies. And I think in the long run, the only question is who develops them, us or China and India. I think the main consequence of us pulling out of the Paris Accord was it made it less likely that we'll be the strong economy of the future and more likely that someone else will be.
Actually, I've heard of the recent discovery about the U.S. about the human-made photon synthesis system. Will that be the solution for this?
Well, so the question was about like human-made photosynthesis systems. That's one of those technologies that in principle could draw carbon dioxide out of the atmosphere. So that is a potential long-term solution if we're already too high, like I think we probably are. But in the short term, we've got to quickly make this change. And I'll tell you one more story, because how long, you hear, for example, the Green New Deal that you hear a lot about. I love the fact that people are aspirational. If there's any criticism I have of it at all, it's simply that I think this is the number one problem, so I wouldn't mix in a bunch of other stuff at the same time. I would deal with this one first. But the Green Deal has been criticized for saying, we should make this transition in like 10 years. So one of the questions that I often asked audiences, or people ask me, was if we really put our minds to it, how long would it take us to make this transition to these alternative sources? And the typical answers that audiences gave that I thought were accurate were sort of 20 to 50 years for the transition. And I did this talk at a retirement home, a very well-educated retirement home, lots of former professors in there. And this question came up. And a 95-year-old man in the first row said, and of course I love this because, nobody really calls me a young man anymore, but he said, "Oh, young man." He said, "Oh, young man, 3 to 5 years max." And I was like, 3 to 5 years? Nobody ever told me that before. He says, "Oh, young man, I lived through World War II. And in World War II, we completely changed the entire industrial manufacturing economy and base of this country in less than 3 years. Why? Because we had to in order to win that war." He said, "It's just a matter of how much we care. If we had to, we could do it in 3 to 5 years." Now, I'm not sure the threat is obvious enough to most people for us to do it like that, but I do believe if we put on that carbon tax, I think we'd see the innovation way faster than people are expecting. And I wouldn't be at all surprised if we started a carbon tax like this today, if 10 years from now fossil fuels were pretty much a thing in the past. Any more? Yeah.
Hi. I have 2 questions. Sorry if I asked something that you talked about. I have to run out a couple.
No problem.
But, so my first question was that you had mentioned that the reason why Venus is so much significantly hotter than Earth is because it's about like 200 times the amount.
200,000 times as much, yeah.
1,000 times the amount of carbon dioxide in their atmosphere. What causes that? Especially thinking of, when I think of carbon dioxide, I think of plants.
Yep.
Plants.
Correct.
So where do they get all of that from?
So the answer to the question about where Venus got all its carbon dioxide from, carbon dioxide gets into an atmosphere in the first place by being released from volcanoes. And because Earth and Venus are essentially twin planets, we would expect Earth and Venus to have produced the same amount of carbon dioxide from their volcanoes. And so the real question is, given that, why is there so much more carbon dioxide in Venus's atmosphere? And the answer to that is, in fact, the Earth has just as much total carbon dioxide, but instead of being in our atmosphere, because we have oceans, it dissolved in the oceans, and then it turned into limestone. So our limestone carbonate rocks contain 200,000 times as much carbon dioxide as our atmosphere does. And so, and if you want to know then why did Earth have the oceans that dissolved the carbon dioxide and Venus didn't, that actually does get traced to distance from the sun. So in a way that does become the answer at the end, but not in a direct way. And
so the second question was,
okay.
Does Venus have a magnetic shield?
No, it doesn't, but its atmosphere is so thick that even with the solar wind stripping, that's been pretty insignificant over time. That is very significant for Mars and would be significant for Earth if we didn't have, but Venus's atmosphere is so thick that all the solar wind stripping is insignificant in comparison.
The other thing that really surprised me during your presentation was how much you were talking about the greenhouse effect affecting global warming, how it's like the main thing. When I think of global warming, I think of like holes in the ozone layer. So, I don't know, I guess just in your professional opinion, like, is that even important?
So the question is about the ozone hole and what's its role. So the answer is those are two different problems. The ozone reduction is caused by chlorofluorocarbons undergoing reactions that destroy ozone in the atmosphere. Now, those same chlorofluorocarbons also are a greenhouse gas, so the same chemicals can contribute to global warming, but they're really two separate problems because the main contributor to global warming is the greenhouse gases being released by the fossil fuel burning. And when CFCs do contribute to this, it's also through the greenhouse effect. It's not through the ozone destruction. It's just they both happen together at the same time, different problems.
This is a little comment, a question about the super wealthy amongst us. If you think of Richard Branson, you know, the British entrepreneur who owns Virgin Airlines and 400 other companies. I think he pledged about 10 years ago that all the profits from one of his many airlines was going to be used for climate change research, and he was going to have a whole bunch of organic chemists to make a jet fuel that doesn't put out CO2, which I think is impossible. And then you have Elon Musk, you know, building rocket ships that can land back on their feet. And Jeffrey Bennett seems to be obsessed with commercial rocket travel. How can we get these guys to grow up a little bit and face these problems squarely now?
Well, you know, that's an excellent question. I would say on the positive side, a lot of them actually are doing a lot, like you mentioned, making efforts. Bill Gates has invested a lot in trying to develop safe nuclear power and so on for around the world, small modular nuclear power plants. I'll just make one other side comment there on the jet fuel. So, of course, it's still going to emit carbon dioxide, but if your source of it is algae-based biofuels, then you absorbed just as much carbon dioxide in growing it as it releases, so it's in fact carbon neutral. And the Navy already has a ship that runs off algae-based biofuels. Commercial airlines, my brother-in-law was actually the CEO of Continental Airlines when they first flew a algae-based biofuel jet, and he wanted to have them convert all their jets over, but cost-wise, they wouldn't have been able to compete with the other airlines if they did that. But there are ways to replace jet fuel that do not contribute to global warming because of where the fuel comes from. And in fact, some of those algae-based biofuel companies also have the technology where, in addition to the fact that they're absorbing as much as they're emitting, some of it actually gets turned into waste that becomes bricks, so they actually do draw out carbon dioxide from the atmosphere, so it's even a net positive for the atmosphere. So yeah, you don't have to stop flying planes, you just have to fly them with the right fuel, and so on. Yeah.
How do we as individuals do anything that makes a difference of this, other than changing our light bulbs to better light bulbs? What are some things that you could suggest that we can, or can we? Is there really? Well,
I guess that's where the letter to the grandchildren comes in. You got to think about what you can do. But I would say, from my standpoint, the most important thing we can do is only vote for people who will support a carbon tax. And as far as whether it should be this tax and dividend plan versus some other form, my perspective, I have a lot of liberal friends who say they don't want to have the dividends. They want the carbon tax to be used to fund other government programs, including research into renewable energy and stuff. And, that might be wonderful, but guess what? The Republicans won't vote for it. Whereas we have a whole bunch of Republicans, like those officials I talked about, who will vote and support for one that doesn't increase the government's total revenues. So my answer is go for that one. If you want to increase the government's revenue for spending, pass that separately if you can.
Do they even talk about that?
Like I said, this bill, the tax and dividend plan, was introduced in Congress by a bipartisan group in the House of Representatives in December. I forget what it's called, but you can look it up easy. The Citizens Climate Lobby is the group that first put this up, CCL, and you can go to their website and read all about the progress being made on that. But yeah, this issue has not risen up high enough. good news again is polls show most Americans now believe that this is a real problem. Because how do you miss it now with the hotter summer days and the extreme weather events and so on? But it hasn't risen as a high enough priority yet. So I think talking to your friends, talking to other people, and saying, look, this should be number one at the top of our list of problems to deal with. So let's deal with it. That's how I think we can make a difference as individuals.
Do we know how much CO2 there was in the atmosphere in the 4.5 billion years before those ice cores?
We know for a lot of periods there are ways of getting what it was from some of the geologists in here probably know better than me exactly what things we study, but we can get pretty good ideas for large parts of human history, Earth's history.
You just led into something I've been thinking about and listening to you, but just quickly. My thought is that people don't do anything about this primarily because people procrastinate and they're selfish. I know there are a few ignorant people that don't buy into this, but other than economic pressure, and that may be our answer, and technology and so forth, do you see any major cause, other than forest fires and inclement weather and things that are easy to connect? Is there going to be some other thing, a food chain collapse or some major thing that would shock people into?
Well, it's possible there will be, but I think we got to hope not, because that would be quite devastating. I'm still not sure. It is interesting. In places where they've been hit by more extreme weather events, people are much more likely to believe it than in places where they haven't so far been hit by an extreme weather event. So even with some devastating thing, I do worry that the rest of the people who aren't affected by it, it still might not change them. I think we need that economic pressure. I think that if we put in that, I think people respond, at least to me, even people who are very, very conservative respond to the idea that we're overpaying for our fuel right now, that these are real dollars. One fun thing that I've done with a few groups is, I called these socialized costs, and there's a reason I use that word, right? Because if you really think about it, that means that our current energy policy is a socialist energy policy. So who's in favor of socialism? Usually not the people who claim to like our current energy policy. And when you explain to them, you're actually supporting something that's socialist, sometimes you get a reaction that, oh, maybe I should rethink this. The true free market answer is to have the market bear the costs, not socializing them around. And that's part of why I think we can get agreement on the politics of that. And again, plenty of examples, not enough examples, but plenty of Republican conservative examples of people who've said, yeah, we got a serious problem. In fact, there's, on college campuses, the college Republicans, there is a whole set of chapters of college Republicans around the country that have formed a group to advocate for this action as college Republicans, because they said, hey, we're Republicans, we're conservative, but on this issue, we get it. And that's what we need more of. We need to find the solutions that bring everyone together. And I guess I should mention, I usually say this and I forgot, but on that letter to your grandchildren, we often hear about all this political polarization that we have in the country today. And so you say, it seems like there's nothing we agree on. But it turns out one thing that we do all agree on, you go from the most extreme right to the most extreme left, and pretty much you're going to find every single person agrees that we want to make the world better for our children and grandchildren. No one disagrees with that. And that's why I think if you think about that letter to your grandchildren, it doesn't matter where you're coming from, you're going to think hard about whether what you're doing today is in fact to their benefit. I would like to see that. Everyone thinking about it that way.